Well, thank you, everybody. I'm really honored to be here. And thank you for the Land Trust for inviting me to come and speak. So I'm Kevin O'Connor. I am the director of the Central Coast Wetlands Group down at Moss Landing Marine Labs. I'm not going too far south. We're just a little bit outside of the county. I'm going to talk to you about the restoration work we've been doing there for the past 30 or so years. Not me personally, but my team as a whole. But I thought I'd start off with where I came from. So my circuitous route of where I've gotten here today, I started off in Bolinas, California. Do people know where Bolinas is? Marin County, out on the coast? Woo, Bolinas. I grew up on a ranch in Bolinas, raising cattle, and then quickly got out of West Marin and went to UC Santa Cruz and did a BA in environmental studies and biology there, and then went on to the NOAA Fisheries Lab here on the west side and worked there for a year doing ground fish ecology research, looking at stock assessments and measuring the rings and otoliths, which are the ear bones of fish, to see how old they were. There's a lot of microscope work. I then went on to San Diego State to get my MS in marine biology. I did diving out on the island of Catalina, looking at kelp forest disturbance over 3 years and the effect on fish communities. I finished off my time in San Diego, the city of San Diego, doing restoration in an estuary in Mission Bay called Rose Creek, I forget. And then ended up at the Central Coast Wetlands Group back in the end of 2007. I've been there ever since. Started off as just kind of a low-level project implementer and moved up to a manager, and then I took over the directorship 2 years ago about now when the former director passed away, Ross Clark. So a little bit about the Central Coast Wetlands Group. So it was started back in the 1990s by this kind of crazy guy named John Oliver. He is a benthic ecologist at Moss Landing Marine Labs. Quite an interesting fellow, longtime family friend of mine. And he was doing offshore research, looking at the benthic community of the sea bottom, and noticed a lot of pesticides, nutrients, and whatnot, and then turned inland to kind of address that. So back in the 90s, he started this habitat restoration group there at Moss Landing Marine Labs with the goal of restoration of natural processes in altered landscapes. How can we restore those natural processes to enhance the quality of water and habitat on the landscape? And his main focus was the Morro Coho Slough Management and Enhancement Plan. The Morro Coho Slough, in one of the next slides, I'll kind of point out where that is. It's just south of Elkhorn Slough. This was a plan that was drafted in the 1990s and didn't really have anyone implementing it. So his team kind of took on that role and started doing it, and did also restoration actually in Harkin Slough. That's one of his other projects he worked on. There we go. So Ross Clark and Gage Dayton actually started the Central Coast Wetlands Group at Moss Landing Marine Labs back in 2005 with a grant from the US EPA. The charter was established in 2005, and the overall effort was to provide a regional voice to state decision makers. Ross Clark here, he had been working at the Coastal Commission for about a decade, a lot of interactions at the state level, but noticed that the Central Coast wasn't really being represented in those decisions and in those conversations. So he wanted to start a research group that could start collecting information, collecting data, representing the Central Coast in those decisions. And came up with a mission to coordinate the advancement of wetland science and management on the Central Coast. So always looking forward to the future. How can we make the science better? How can we make the restoration better here on the Central Coast? And that was my first day on the job. So at this point, we are a grant-funded research affiliate at Moss Landing Marine Labs. It's our technical designation. So we don't really take part in the academics, but we do hire students and do research there. And our work is really focused along the Central Coast region, but we have projects all around the state, and our team has grown. So this is us at this point. That was a few months ago. Our research areas and focus areas fall into 5 different categories. We do water quality improvement projects, a lot of wetland monitoring and assessment, developing tools for the state of California to better assess the condition of their wetlands. Overall regional coordination, looking at water movement, sea-wise resilience planning, things like that. A good amount of habitat restoration, and then, as I said, resilience planning and implementation projects along the coast. Why does this all work? Why is this important? Why are we doing this work? Well, wetlands filter a lot of pollutants and recharge the groundwater and support the biodiversity of the Central Coast. Coastal habitats reduce flood risk and buffer wave energy. These things are increasing as climate change is intensifying, especially here on the Central Coast, and we have a lot of natural systems that will be affected. Restoration brings ecological and community benefits, and this is well known especially on Beach Ranch, with the project incorporating both natural habitat restoration as well as sea level rise and climate change resilience into the landscape. And finally, tracking these benefits is always essential. So coming up with monitoring programs that will better track the change over time and the effect of your work. So I was going to zero in on two different, mainly here, water quality improvements and habitat restoration in the Morro Coho Slough, and then kind of at the end veer into some coastal resilience planning that we've been working on. That ties in nicely. So the Morro Coho Slough, here's our landscape we're working in. So we're down here in the middle part of the bay. This is Moss Landing, power plant right there. Here's Elkhorn Slough, Moss Landing, and Castroville. This is the Morro Coho Slough watershed. That's a relatively small watershed, and there is a slough going up it here, and then some upland habitats. You see we have a lot of irrigated agriculture, also a good amount of oak woodlands, but down along the slough, it's very much developed with irrigated ag, diked and drained lands, water quality issues, and whatnot. And the portion of the slough from Highway 1 up to the railroad track here is actually a marine protected area. So this is an image that guy John Oliver put together based on what the landscape would have looked like pre-contact. It was very wet down there. The whole central Monterey Bay between Pajaro River and Salinas River, going all the way out to Castroville and up to the city of Salina. Salinas was wet. There were freshwater lakes between the ocean and all the way up to Salinas. Birds everywhere. There was so much fresh water that you could refill the fresh water in your ships offshore because there was just artesian fresh water coming up. Those were the stories, at least. And here we are, present day. You can see it's been heavily impacted. Here's the same slough. We've got irrigated agriculture. We actually have some conservation lands here that I'll point out. And then we have the whole complex around the power plant and the National Refractory where they were doing kind of industrial level work. So I thought I'd take you a little bit through time of the Morro Coho Slough. So this is the Morro Coho Slough here. Salinas River, Elkhorn Slough, Morro Coho Slough. These are the 1854 T-sheets. One of the earlier maps. You can see we've got good connection everywhere along here. So Salinas River is connecting with the Elkhorn. Pajaro's up here coming down connecting. Morro Coho Slough is connecting. It's all a wonderful landscape of wetlands and flowing water. However, in 1906, the Salinas River was rerouted and to its current location where it spits out south of Moss Landing. So there was no longer all the sediment and fresh water from that river coming into the estuary.
Why?
That was to allow for less disturbance, basically in the estuary portion, for where they were doing a lot of the fishing and boat movement and onloading and offloading of supplies. Moss Landing Road was placed, the first kind of restriction on Morro Coho Slough was placed in 1910. And then in 1946, the harbor mouth was opened. So here you can see, this is the harbor, 1946, which completely changed the system. Elkhorn Slough went from more of a depositional environment to an environment that is losing sediment because of the amount of salt water going in and out every day. Here we are in the 1970s. We have more irrigated agriculture, disturbance on the land, more diking and draining of wetlands. In 1989, after the earthquake, the culverts that went under Moss Landing Road that fill and empty Morro Coho Slough were rebuilt. And that was a key moment in time because the system before then had been a little more leaky. At that point, they put in new tide gates and it was much more restricted. And with that came the requirement by the Coastal Commission to draft a management plan. And in 1997, the Morro Coho Slough Management and Enhancement Plan was actually adopted by the county, incorporated into the local coastal plan, and then needed to be implemented. And here we are in 2022. We've had some changes at this point in 2022. We've got conservation lands in place. What else has happened? We've got additional agriculture still going on here. You can see some of additional restoration projects that have been put in place. Overall, kind of the peak of disturbance was back in the late 1990s, early 2000s, and since then there's been a good amount of restoration that's taken place. So the long-term impact of that century of development on the Morro Coho Slough, diking and draining to allow for ag production. So it's a very productive environment, but it's wet. So they had to put in tile drains and ditches to drain the land to allow for agricultural production, similar to the Pajaro Valley. Loss of fresh and brackish water habitat. All those areas that were diked and drained were those former wetlands that provided a lot of habitat, and that was gone. Also, a kind of isolation of threatened and endangered species. They're still present there, but their habitats have been reduced. And then, of course, water quality impacts. All of that irrigated agriculture leads to huge amounts of nutrients and pesticides coming off into the estuary. So the actual management enhancement plan for the lower slough came up with some ideas and some efforts of how to move forward within the lower slough to enhance the habitat. So retain both saltwater and freshwater habitats within the lower slough, maintain known habitat for rare and endangered species, maintain existing saltwater flow in the lower slough below the bridge, utilize treated reclaimed water to recharge aquifers, create freshwater conditions in the lower slough, so bring back those freshwater wetlands, retain water in the lower slough through the creation of impoundments, find areas where are low spots on land, put in little dams and create new ponds, maximize freshwater in the lower slough through increased runoff and use of reclaimed water, so taking all the agricultural waters and reusing them for wetland restoration, and recognizing there's a long-term need for maintenance and monitoring of the system. It also came with a whole set of a very fuzzy picture, because it's from 1996 and it was blurry back then and it's even more blurry now, of site-specific actions. And this was kind of the roadmap of where we all started out. How are we going to do the projects and where are we going to do them? So I'm not going to go through all of them, but just to say there was a map and we started implementing it back in the mid-1990s. And as of 2023 or 2024, this is how far we had gotten. So you can see blue bars are done, green is in progress, and at this point some of those are actually done, and then the red bars are future progress. And here's just lays out kind of the sequence of events with different grants and major actions that took place in the Morro Coho. So in 2001, the first purchase and restoration of 200 acres took place. And then in 2005, there was another major purchase of 200 acres and restoration efforts. And then through time, we've gotten additional grants from the EPA and the State Water Board, trying to think of California Department of Food and Agriculture, Ocean Protection Council, so all different sorts of state agencies. We've put out grant proposals and gotten additional funds to do additional restoration and monitoring and research in the Morro Coho, which has resulted in a great map of accomplishments. On the actual landscape, this is what that looks like. So here again, we have Moss Landing, the Morro Coho Slough. We have the blue outline is the outline of the watershed, the extent of that planning effort. The green areas are either fee title purchase or easements. This one is as well, but that's an ag easement, so that's a different color. And then kind of these outline green areas are actual restoration projects that we've completed. All of this has been done in collaboration with Elkhorn Slough Foundation. They're the main recipient and takeout partner for all the lands and the easements. It's resulted in about 200 acres of wetland and upland restoration across 600 acres of conservation lands.
It mentions a bioreactor. Is that the same thing that the slough is doing, with converting restoration waste into charcoal and into...
So this is referring to a wood chip bioreactor.
Yeah.
So basically we have a big bathtub, you fill it with wood chips, and you run your dirty ag water through it, and there's a chemical digestion of the nitrates from the little bacteria.
Okay, so this is water quality.
Yeah, water quality, yeah.
Thank you.
You're welcome. So taking a step back, what are the driving forces for all this work we've done? We had a plan, but what else is going on in the watershed? So we have serious nutrient enrichment impacts, and that can come out in the form of hypoxic conditions, so low DO in the estuary. You can have harmful algal blooms or just general algae blooms. So here is the lower Morro Coho Slough. This is Highway 1 here. This is the old hole enchilada, if you know where that is. This is Moss Landing Road and the snack shack, and you can see it's very green. So that's a result of the huge amounts of nutrients coming into the system. Species-driven management. We do have special status species in the Morro Coho Slough. We have, in the lower portion brackish areas, we have tidewater goby, as well as the brackish water snail, each having their own kind of salinity and requirements. Then in the upper slough, we have freshwater species, including the California red-legged frog, California tiger salamander, and the Santa Cruz long-toed salamander. So our efforts kind of focused around enhancing areas where these species already exist, and then identifying areas where they could be restored to increase the amount of habitat for those species. And of course, oh, go ahead.
Yeah. Have you removed all the eucalyptus from the area?
We do not have the problem that Elkhorn has. So Elkhorn Slough has a lot of the eucalyptus.
Yeah.
In the lower part of the Morocco Slough, where we've been doing our work, we don't have eucalyptus.
Okay. So it's just all in the upper part.
Yeah, it's mainly in the upper part and then over in the Elkhorn watershed.
Okay. Is there any idea to remove it?
There's been a lot of work by Elkhorn Slough to do extensive amounts of removal. Yes, yeah. And I believe they have additional funds right now from the NOAA grant that has come to this region to do additional removal of eucalyptus.
Right. It
Yeah.
didn't look very healthy the last time I looked at it.
The eucalyptus?
It was dying.
We like that.
That's
a good thing.
I know.
That's great.
It didn't say good for that piece of land. I was wondering what is going on, you know. But I've seen that happening in eucalyptus in other places as well. But it's not a local plant.
No, it's not. No, yeah.
You know, and unfortunately, it's all over our coast. You know, it got planted to make money, and
Right.
and it didn't solve that.
Yeah, and it's got the
problem.
chemicals in the leaves
Right, and
that prevent growth of other species, and yeah.
But it is toxic.
It
has
is.
some toxic effects.
So
The
one
only thing
solution
that
would be
goes under it is poison oak.
We could just get a whole bunch of koala bears, bring them over,
Right.
have them start eating it.
Kangaroos and things. you know,
Exactly.
bring them over.
That'll be great. They can hang out with the deer. So I'll continue on. But just to say, there are special status species in the watershed. In some of our restoration projects, we're focused on increasing the habitat requirements for those species in the slough, or addressing the loss of those habitats. And of course, in the end, it all comes down, where can you actually do a project? Where can you find a landowner that actually will work with you? So we identified mostly low-lying areas that are less productive for agricultural production. And that was usually where we get our foot in the door and talk to the landowner and figure out a path forward. So this is not actually in the Morro-Coho. This is over on the Old Salinas River Channel outside the watershed. But you can see during the 2021 flood, there's a lot of land that is not actually exposed anymore. It's underwater. And we've actually developed concept designs for restoration projects along the Old Salinas River Channel to address water quality impacts there as well. But similar effort in the Morro-Coho. Where are those wet areas that they can't farm or only get one rotation out per year, and work with them on identifying those for restoration actions. So I thought I'd just go through some of our tool set that we've used in the Morro-Coho. So we've got agricultural buffers, we've got freshwater impoundments, which are really habitat focused, and then we've got treatment wetlands that are both habitat and water quality enhancement. So up at the ag buffers, Calcagno border here along the slough, buffering the slough from a dairy farm. Number 2, the Dolan border over here, buffering it from irrigated agriculture. 2 different freshwater impoundments. This one's along Highway 1. You can actually see it when you're driving south towards Castroville. It's called Totino Ponds. That was put in the 1990s, and it's still there, going strong. And the Catellis parcel, we put some ponds out there using agricultural return waters. And then we have our 3 different treatment wetlands. So we've got Seamus. This was put in 2005, I believe. We've got number 6, the Castroville Slough Treatment Wetland. That was in 2016. And number 7, the Totino 2 Wetland, which was put in 2022. So I'll just quickly show you some images of each of these sites. First, some ag buffers. So we're filtering runoff from the watershed. First, we have the Calcagno farm border. So you can see what it looked like before the work. In 2008, the cows were going right down into the slough and having a great time. Cows really do like mud, but the slough didn't appreciate it. So we got some funding to put in fencing. And here's after a year or so of recovery. We did a lot of planting. Wasn't necessarily successful, but then nature did its own thing. And here we are a few years later, and we've got a great buffer between the cattle pasture and the slough out there. Here we have the Dolan farm. You can see irrigated ag, a farm road, and they were just disking it down to dirt at the time. This was part of an easement that the Ag Land Trust held, and we worked with the RCD down there and did some restoration along there, and did a little fencing to keep the established line between the active ag and the conservation area. Fences are really nice for doing that. And then we have a nice buffer here between the estuary and the irrigated agriculture. So freshwater impoundments, restoring freshwater habitats within the watershed. I've got a few to show you here. So this is the Totino Ponds. This has been done back in the mid-1990s by John Oliver. So here's Highway 1. Casterville's over here, Moss Landing's over there, and it's a big whole bunch of willows on the side of the road. And you can see it as you drive south. Before that, it was just a disked area that was used for storage, a lot of trash, old vehicles. So he worked with the landowner, Hugo Totino, and Hugo let him do some restoration. So they removed all of the old machinery, regraded the area, and put in some small ponds. And here we are, almost 20, 30 years later, and we've got a functioning wetland still there. This one's pretty unique in that it receives both agricultural runoff from the adjacent farm, but also it's at the end of the purple pipe system, and that's the recycled water from the Marina Coast Wastewater District. And there's a little leak on that thing, which is really nice. And it allows us to fill our wetlands when we need to. It's kind of just a pressure valve, and then sometimes there's a little too much pressure, so the water comes out, and we use that water to fill our ponds.
How bad is the pesticide contamination of these ponds and?
Very good question. Yeah, so we did a study, I think about 4 years ago now, because there was concern by the Elkhorn Sioux Foundation is if we were having accumulation of pesticides in the wetlands that we were building as compared to kind of the background level of pesticides in the area, which is already elevated. And we took samples both inside of our treatment wetlands, outside of our treatment wetlands, and then in theory, areas that hadn't been disturbed. And we did not find any elevated levels within the treatment wetlands as compared to the adjacent habitat. So we weren't having any kind of Kesterson wildlife effect here. I don't know if you remember the selenium and Kesterson and the accumulation in the Central Valley and deformed birds. That was the concern, but we did not have anything like that going on. And there is some breakdown of pesticides. When we build these treatment wetlands, it slows the water, it spreads the water. There's a lot more solar irradiation hitting those particles and breaking them down, and some breakdown by the plants as well.
So is there any kind of stipulation for these agricultural buffers to be organically farmed?
No, not at this time, no. There's a new project, an effort on one of the parcels actually in the Morocojo that will be converted over to organic agriculture in the next year or so. But in general, it is not organic at this time.
What crops are they growing? Is it one or two?
It's interesting how much it's changed. So back about 15 years ago, there was a lot of artichokes. A lot of artichokes. We were just surrounded on all sides by artichokes. And since then, it's really converted over to strawberries, leafy greens, and brassicas. Yeah.
Brassicas.
Like broccoli,
Okay.
cauliflower, collard greens, things like that. Yeah.
The coastal veggies.
And the amount of acreage of artichokes has really shrunk a lot, which is interesting because Castroville is the artichoke capital of the world. So this is the Catalyst parcel. This is one of those 200-acre parcels in the Morocojo. So here's where are we? Here we are. The mouth of the slough, and Highway 1 is over here. That's the channel going up. So this parcel had been kind of diked and drained a long time ago. And our solution was to basically just plug some of those drains and encourage some ponding areas, which allowed for some really neat things to happen. It went from an area kind of devoid of wetland habitat to these great kind of ephemeral ponds that supported migratory bird habitat. Lots of birds came in, loving the fresh water. And there's a special salt clover that really liked the disturbance that was occurring from the restoration activities. Treatment wetlands. So the last big thing we do in the watershed is treatment wetlands. And we in general size our treatment wetlands bigger than they need to be so that we have habitat in addition to just cleaning the water. In general, we capture and treat large volumes of runoff from upstream ag lands. This improves the water quality, of course, by removing nutrients, sediment, pesticides before they reach the Morocojo Slough and the marine protected area and out to the Monterey Bay. And these are multi-benefit design projects so that we're both supporting habitat, we get community engagement groups coming out there, and we have water quality enhancement, of course. There's both treatment wetlands. Treatment wetlands need a lot more space because you need an area where the water can all spread out. You usually want it about this deep. Got plants growing up through it. The water flows through, it gets filtered, biological, chemical breakdown. Higher construction costs at the beginning because you have to have this land, you have to plant all the plants. However, long term, there's a lot less maintenance as compared to this one, a wood chip bioreactor. And if the water gets too high, it's okay because you have a wetland and it can just be there. And then when the water goes down, it's still a wetland. Now, wood chip bioreactors, these are a very specific use. You have to have water that's free of sediment. So you want to have water that's very clean going into it, because if sediment goes into it, it's going to clog up your wood chip bioreactor. These are systems where you flow nutrient-rich water through a medium of wood chips, and there's chemical reactions that take place by bacteria using the cellulose on these wood chips to break down the nitrates and turn it into nitrogen gas. But you need less land, there's less food safety concerns, lower construction costs, but you have to replace the wood chips once in a while. There's one out at Pajaro that has been there
On our
for,
Watsonville Slough.
yeah,
Yep, that's been there for,
a decade?
well, yeah, about a decade.
Yeah. And we
It
have
has only
one,
had one replacement of the wood
yeah.
chips, and is really effective at
Yes.
reducing nitrate.
We've put them in areas where we have tile drain water. So tile drains are down in the lower part of the slough. These are drains that are put out in the fields to lower the elevation of the groundwater, the shallow groundwater, so that the plants that you're growing, their roots aren't getting wet. So they've got pipes going all out into the dirt. It all comes out and drains into a ditch. That water is very clean in that there's no sediment in it. It's just full of nutrients. So that's what we've hooked up to our bioreactors. Okay, here's another one, Seamus Ponds. This is further up the slough, the next 200-acre parcel that was purchased. You can see all these areas. That's the runoff from the irrigated agricultural. Goes into a perimeter ditch, and then we, along with Elkhorn Slough Foundation, we purchased this land and did a restoration project, putting in a treatment wetland and then a couple ponds for bird habitat. And you can see the nitrate levels at the start. First pond and second pond, we have an over 90% reduction in nitrate due to this wetland, which is really nice. And we've got some great bird habitat as well. About a decade later, we realized that the habitat benefits of the project were greater than using it for treating water quality. So we put in a pre-treatment bioreactor. Kind of the first one we put out, it's really big. It was way bigger than it needed to be. We were overly ambitious, and then realized once we had this big thing we built, then we had to fill it with wood chips. And we're like, oh my God, this is a huge hole. So we had it took a long time. But we eventually filled it and ended up actually cutting it in half. We only used that much of it because we really didn't need, this is a nice little seasonal wetland now, but this side is an actual wood chip bioreactor. So see, the water is relatively clear. We pump it through the bioreactor and then it goes out to the wetland. And so the water entering the wetland is now 50% lower in nitrates before even hitting the wetland. So it's got better water quality before it even hits the area where the wildlife is located. And then finally, the PG&E Castroville Slough treatment wetland. So this is our one we did in 2016. Again, that's Highway 1. This was a disked field for a very long time, too wet to farm. Here's what it looked like on the landscape before we did our work. And this was one that was done back in the 1990s by John Oliver. So almost 20 years later, we were able to do this. So this is a 13-acre treatment wetland here, and then a 5-acre habitat pond. It's 1.5 kilometers long. The water starts here, goes through this whole system, and rejoins the Castroville Slough. It's beautiful habitat, and these are measurements of nitrate concentrations at locations along the treatment wetland here. So starting at the beginning, working your way to the end, and you notice by the end, we don't have nitrates anymore. Actually, halfway through, we don't have nitrates anymore. So by the time you get to here, the water is pretty much cleaned up. And this, we call this our polishing zone. That's also where the birds like to be too. It's a big runway here that the birds like to use. And then we had extra space, and PG&E gave us some funds to put in some habitat ponds, which was really nice of them. And then the last one is our most recent, 2022, the Team 2 restoration project. This is a 35-acre wetland restoration project. This one, we don't have as much of a defined inlet and outlet. It was designed both to enhance water quality, so we've got some agricultural inflows that go into the ponds, but also it was designed as a floodplain restoration project. This was an area that was disked for a very long time. There was a small berm here at the end that would flood sometimes. We put in a much higher berm here to protect the ag land. That was one of the agreements of the purchase. And then we put in inflow, outflow at each end. So during high water events, the whole area can flood and then hold on to that water over the course of the dry season. And we designed it to be both fresh all the way to brackish. So we've got parts per thousand of salinity here. Darker blues are more fresh and yellow is more salty. So the water comes in at the top and then comes out at the bottom. In this case at the bottom here, and we have a two-way culvert so we can get some salt water from the slough in there. I think we have time to watch this. But there's a little video here, which I thought you would enjoy. Here. So this is the inlet right here. Those are our two main culverts that only get water during the winter, during high flood events. And then we just put in a series of ponds and islands. So the water flows all the way out here, back here, and comes all the way back to the slough.
How far into the restoration is this? Like a couple years ago?
This is probably 2023. A lot of this, the pickleweed came back instantly. We didn't have to do anything, really. So we focused our efforts on the berms and this kind of big flat area and on the islands. But this was probably a year or two into it. But it was amazing how quickly. I mean, if they stopped disking it, it would have just covered in pickleweed. So we were nice that they actually did keep disking it so we could do our earthwork. But then this is one of the agricultural inputs here. So there isn't a focused area of treatment, but it spreads out. And then there's another one right there. So we've done a lot of work across a large landscape. Can we quantify the benefits? What have we done to the overall watershed health? Can treatment systems achieve watershed scale nutrient reduction? So here we have various restoration projects. That's the Castroville Slough Treatment Wetland. The CMIS restoration project I talked about. Totino 2 is right here. We've got these fingers restored, put in treatment wetlands there. We did some treatment wetlands up here to remove nutrients from the cattle operations. And then here is a long-term monitoring location that's been monitored by various long-term monitoring groups for about 30 years, including the Central Coast Water Board, Elkhorn Slough Foundation, Agricultural Preservation Water Quality Incorporated. So we have a lot of data at one point from a lot of different monitoring programs. So our first effort was to determine the amount of nitrate that we're removing as a result of all of these treatment wetlands. So we had various calculations. I'm not going to go through all this, but what's really cool is the number at the end, which is 11,000 kilograms of nitrogen removed per year by our treatment wetlands in one watershed, which is a lot of nitrogen. But here's the neat part. So this is the graphing of all of the water quality from all these various monitoring programs, MPCs, and other things at the same location. We've got the amount of nitrate there. We've got time from 1989 all the way up to 2020 about. And you notice there were definitely peaks back at the beginning. And as we move this way, those high points are disappearing. So here's the implementation of the CMIS restoration project. And then here's the implementation of the Castroville Slough Treatment Wetland project. So after that one, we definitely have a complete lowering of the overall nitrates seen at the monitoring location. There are water quality objectives for the slough by the State Water Resources Control Board. There are general, and then there are wet season and dry season objectives for the slough. And we see from 1989 to 2006, when we had no treatment wetlands in place, there were a good amount of exceedances of those water quality objectives. From 2006 to 2016, after the implementation of CMIS, but before PG&E, we had fewer, obviously here. You can see these numbers falling. And then after the implementation of the Castroville Slough Treatment Wetland, we have 0% exceedances. So it was a huge, huge success. But there's always work to be done, right? So this is our long-term monitoring station at the mouth of the Morocojo Slough, right at Highway 1. It's an in-situ monitoring probe, and it can monitor the amount of nitrates, the flow, the depth of the water, the salinity, dissolved oxygen. It does a lot. But what I want to show you here, the blue line is tidal. So those are the tides going in and out of the harbor every day. So this is over a 3-day period. The orange line is the elevation of water in the Morocojo Slough. You can see it's heavily muted because it has tide gates. The water can't go in and out, it just oozes. The green line is the flow of water coming out of the Morocojo Slough. So when we have low tide, water is flowing out. When we have high tide, there's no movement of water because the tide gates are shut. And then finally we have nitrates in purple, and what you notice is we have these peaks of nitrate at high tide. And that's when water is coming back up the slough from the harbor. So we're getting high nitrate water from the harbor, which is getting water from the Tembladero Slough and the Old Salinas River Channel and Elkhorn Slough. So even though the water in the Morocojo has been cleaned up, there are other sources of nitrates still in the system. So our work is never done, basically. This all ties into kind of larger efforts on the Central Coast around agricultural water compliance. So the State Water Resources Control Board and the Central Coast Water Board have passed the Ag Order 4.0, which lays out requirements for the amount of nutrients that agricultural production can release into the environment. One thing that we got slipped into that ag order was the allowing for grower-led adoption of water quality treatment systems on a watershed scale to address water quality impacts. So they can form their own co-ops around a treatment wetland, have their water flow through it, and gain regulatory compliance through that. We haven't actually made it work yet, but we're still working on that. But this allows for both farmer benefits of these treatment wetlands as well as long-term maintenance, because one of the requirements of those farmers would be to maintain the wetlands. One of our problems is we put in all these treatment wetlands across the landscape, but we're just a research group at a marine lab. It's not like we have huge sources of money to maintain all these things. So there are ongoing costs, pumps, things get clogged, things break, muskrats put holes in your berms and you have to plug them up. There's a lot. So identifying long-term funding to maintain these wetlands is essential. And we're working with Central Coast Water Quality Preservation Incorporated, which is the farmer organized group for water quality monitoring to see if this model will work in the Morocojo, and then try and expand it to other sub-watersheds throughout the Lower Salinas Valley. So success comes with relationships, of course. How do we make all this happen? We had one watershed and many uses. So with that comes with meeting with a lot of people on their terms, going out in the field, talking with them, kicking the dirt. Ross would go out and kick the dirt a lot. Here's Ross, and he is kicking the dirt. Incorporating concerns into design plans. So of course, earlier on, we didn't have food safety issues. After 2006, there's lots of food safety issues. So identifying those issues and building those into the restoration designs, building buffers into your treatment wetlands. Collecting watershed scale data that can support many uses. Just going out there and continuing to collect data and then figuring out how to use it when it's needed has been really helpful. There's been lots of data collected in the Morocojo, and those 30 years of water quality being collected at one site became very helpful. Always bring opportunities to the table. Don't just come to the table and ask for what you need. Bring something to the table. And always be a good neighbor to your farmer friends, and working at all levels. So watershed, regional, and state level to try and build the processes into the greater system to allow for these types of things to happen. That's really us working with the water board and fitting in kind of a watershed co-op approach for water quality solutions. Next steps for the Morocojo, a coordinated management and maintenance plan for wetland and upland conservation area and restoration areas. We're going to work on that with Elkhorn Slough, and then a sea level rise adaptation strategy. When we started all this work, sea level rise wasn't even talked about. And here we are now, and we are very much talking about it. And I'll touch on that a little bit right now. So looking forward, here we have the Lower Salinas Valley, Morocojo, Elkhorn. This is the Salinas River, a lot of potential inundation going forward. And here we have the Pajaro Valley. You notice there's potential future inundation issues. Here we have some time lapse, so rising tides. Here we have, again, the Morocojo Slough and some of our other sloughs in the area. Potential high tides by 2030, by 2060, by 2100, and then 2100 under storm surge events. So there's two ways you can think about this. Well, we've got ample opportunity for restoration, but we need to have some forward thinking going on here about how that will all happen. and what form it will take, and when you'll have trigger points to allow for retirement of lands. Just a note here, so this is a projection of our conservation and restoration efforts over the past 30 years across a landscape. So these areas that are inundated under 2030 rising high tides, if there wasn't a tide gate, are all the conservation lands that we've already purchased. Some of our restoration projects are in other potential future flooding areas, but you can see there's a lot more work to be done. We have one little tiny one here from 2004. But one thing we can do while we're still in an active agricultural landscape is develop plans. So we have a Lower Salinas Valley managed retreat strategy we put together and help lay the groundwork for a program to support sea level rise adaptation in the Lower Salinas Valley. Immediately though, we can start looking at protective features. So I'm gonna move out of the wetlands and into the dunes quickly here. One of our first steps to address storm-induced coastal flooding. So those beach berms, those dunes, are our first line of defense against rising waters, especially during storm events. So there was a study we took part back in 2013, and one of the most important adaptation strategies is to ensure that the coastal dunes remain functional as barriers to wave surge that could flood the valley. So our first project was between the Salinas River and the lower, kind of the southern edge of Moss Landing Harbor, Salinas River State Beach. We got some funding from State Coastal Conservancy to start doing restoration there. Some of the main issues out at that site, ice plant, extensive ice plant in, coverage of the dune, which really freezes the dunes, doesn't allow for sand transport, and unmanaged pathways. Pathways that would lead to erosion and allow for funneling of stormwater going up and over the dunes. So the main project goals out there on the dunes: enhance habitat quality, increase the resilience of the dune system. So this is a big storm event. You can see there's all these logs and waves going up on the beach, and this is one of the access paths, which is actually low enough that water's going over the dunes. And then of course, we're working in state parks, so supporting state parks in their monitoring and management efforts. So our major strategies: eradicate ice plant, plant natives, and then increase foredune roughness. So this allowed for the collection of sand on those foredunes and enhance the physical structure of the dunes. And we did that with logs, hay bales, things like that. So this is a really neat picture. This was before any of the project took place. This is Salinas River State Beach, and that is all ice plant. And this is it a couple years later after the ice plant has been removed. What was really neat about this site was that we thought we were going to have to do a lot of planting. But after we removed the ice plant, the native seed bank was there, and it just came back. And when you go from a habitat like this to this, right now it's all blooming right now down. You go to the dunes, everything's blooming. It's absolutely gorgeous. There's yellow flowers, there's the paintbrush, and the insect community is just amazing.
What's the history of the ice plant? Who brought it in and why was it planted?
Well, I've heard multiple stories. I've heard the military brought it in down at Fort Ord to help with, preventing dune movement, which they don't want their dunes to move when it's a military base. They want everything to stay still. And also Caltrans planted along highways, again, to keep sand from moving, and it kind of just spread everywhere. But when you have a dune, which is more of a dynamic system, encased in ice plant, it leads to major issues with regards to resilience of that dune. So removing the ice plant and allowing for native plants and the movement of sand between them really helps. So this was the entire park before action, and here is after, and the red is ice plant. And you see there's one spot here, that's not state park. Oh. Yes, but it's a great control, because you can go out here, it's a little private parcel, and you can walk along each side and look at me like, oh, well, this is what it used to look like, and this is what it is now. So someday it will be transferred to Elkhorn Slough. They're then going to transfer it to state parks, and we can go out and do the work. Yeah?
How long did it take to get from your before to after?
That is a good question. I wish there were dates on this thing. But we started in 2016. So this is probably 2016. This is probably the end of the first 3-year grant, so 3 years later. And we're still working out there. And what's neat is we are now working in additional state parks. So we've gone beyond Salinas River State Beach. So now we're working all the way from the Salinas River to the Pajaro River on Smedowski and Moss Landing State Beach, and doing the same thing. So we'll have a complete corridor of restored dunes from Pajaro to Salinas, which will be pretty amazing at the end. We have 2 grants from CDFW for those 2 state park units right now. This has resulted in the development of the Monterey Bay Living Shoreline Project, which is a collaborative effort between our group, State Coastal Conservancy, and Groundswell Ecology and state parks to take a larger regional view of living shoreline resilience in state parks. So the program is really focused on restoring natural coastal systems to build climate resilience, currently being funded by the NOAA grant. We're working with state parks along the entire kind of greater Monterey Bay area. So it starts up on Nuevo and goes down to Garrapata. That's our planning area. Working to streamline planning and implementation processes for these types of projects. We're developing a living shoreline assessment tool so we know how functional the restoration projects actually are and identifying the areas that need restoration. There's a good amount of community outreach engagement, and we're working to implement 4 additional projects by 2030 with the funds from NOAA.
What do you mean by disadvantaged communities and severely disadvantaged communities?
Oh, those are designations by the Department of Water Resources in the state of California for community areas that have a certain average income, basically. So.
And that impacts your program?
That was to help inform one of the grant proposals to, I believe this is a map from one of the Coastal Conservancy proposals, and they wanted to know the proximity between your planning areas and disadvantaged communities.
Do you have a large grant proposal writing
We just write them all the time, just writing grants all the time.
Just noting this NOAA grant is the same grant that's informing the restoration planning that Kevin's going to get to, that we're working on very closely with him. So it's all very tied. The Monterey Bay Living Shoreline Program is very tied to, even though it will affect the Pajaro Dunes, and we're not doing anything land trust wise on the dunes, but we're right next to it and working with the same partners, and it's all coming from the same climate resilient Monterey Bay grant from NOAA. Yep. So it's all coming together.
You haven't had any problems with losing funding with the current administration, have you?
Surprisingly, no.
Good, we'll knock on everything.
Yeah, we had an EPA grant that got pulled, but it was already out of money, so that didn't matter. It didn't really make sense. But this one is amazing.
Yep.
I don't know how we have continued to do this project. Because the name of it is Climate Resilient Monterey Bay. But we're still going along, and it's wonderful. So I've talked about water quality improvement. I have talked about habitat restoration and coastal resilience planning. I thought I'd talk a little bit about how we monitor all the work that we do with one of the programs we've been working on, which actually links in directly to Pajaro at the end. So over the past 5 years, we've been working with the Ocean Protection Council, a state agency, to develop the Estuary Marine Protected Area Monitoring Program for California. Estuaries, as you know, are very dynamic environments providing a lot of services. In California, we have 534 estuaries of varying types. We've got lagoonal estuaries, we've got riverine estuaries, and kind of large embayment bays. Embayment bays, that would be Elkhorn Slough. The lagoonal systems would be kind of those smaller lagoons along the north coast of Santa Cruz County, and the larger riverine would be ones kind of on the north coast of California that don't close up during the summer. It's enough water to keep the beach berm open and to provide continuous contact between the estuary and the ocean, but it's very fresh. Whereas these ones, these pink ones, close off. Those kind of our local small estuaries that close off in the summer. A lot of estuaries providing a lot of great services. California also has a marine protected area network. A lot of people know about the offshore marine protected areas, well aware of those, but we also have estuary marine protected areas that people aren't quite as aware of. So there's 23 estuary marine protected areas in California, ranging from Humboldt in the north all the way down to San Diego in the south. The state did not have a program established to look at the condition of these MPAs and the effectiveness of the designation. So a collaborative group got together representing Bodega Marine Lab, Sonoma State, Moss Landing, CSU Long Beach, Southern California Coastal Water Research Project, and the Water Board, and the Nature Conservancy a little bit, to develop this program We're monitoring estuaries with a standard comprehensive function-based metric system. So we're looking at different functions within estuaries, not necessarily individual species. So how well is the marsh plain functioning? How well is the channel habitat functioning? Is it supporting fish species? Not necessarily which ones are there, but is it functioning well? We have created an assessment framework that is modular and flexible and adaptable to the wide variety of estuaries we have in California. We have tiny ones, we have giant ones, we have ones that are always salty, ones that are fresh some of the year. So we've developed this framework to allow for assessment of those, all in a similar way, so you can compile the data and look at trends across space and time. And then we've developed an integrated, user-friendly data management system where all the data is up online so it can be accessible to other partners and people around the state. This is what that looks like across the whole state. So we've got 21 estuaries that we're currently monitoring. It's expanding it all the time to new sites and new partners. The core team, though, in the north, we've got Sonoma State Water Boards and UC Davis. Central Coast, we have my group, and then down south, UCLA, Squirt, and Long Beach. And those are the estuaries we're monitoring. The type of estuary and whether or not they are an MPA or a non-MPA. But notice, one of them is the Pajaro River. So, we've been out there collecting data at the Pajaro River estuary since 2020, somewhere around there. So we have a good baseline level of information and data to help support the development of the restoration plan for Beach Ranch. And we're also developing a project-specific monitoring plan for the restoration project that is in line with the California Estuary Monitoring Program, which is the larger overall umbrella that we created for estuary monitoring in California. So this will allow for the data comparison and aggregation across different sites for Pajaro and sites along the coast. And these are just some fun pictures of what it looks like when you're off your desk and you're out collecting data. And this is Pajaro right here, doing a beach thing down in the lagoon.
Oh, you should have put the picture of Brian in
Yes.
a wetsuit seining.
Yes.
Brian Largay, our conservation
And that great
director, was
video.
out there last spring
Yes.
on the Pajaro River with the seine and with Kevin's crew,
Yep.
pulling in shrimp.
So none of this happens without partners. And that's what I really want to drive home. There's so many different groups we work with. We've got all the funding groups over here, and all the wonderful NGOs, academic institutions, and whatnot that we work with on our projects. And it's really rewarding to have such an amazing network of people and organizations to work with. And this Climate Resilient Monterey Bay grant that we have for the region is really pulling the region together as well. So yeah, it's an amazing amount of partners. So now, in the last 5 minutes, linking CCWG to Land Trust of Santa Cruz County. So as I said, success comes with building relationships. This was my boss, Ross, who passed away 2 years ago. And he was amazing at building relationships. Let me say, he could go out and talk to anybody about anything, and they would just think he was your best friend. At his memorial, we were at the Coconut Grove, and the question was asked, who in the room thought Ross was your best friend? And like half the room stuck their hand up. So clearly he wasn't, they were his best friend, but he wasn't there. Anyways, everybody loved Ross. And he was great at talking to anybody, but this was a guy at Mattole River who was walking along the beach who had a plastic dog. And Ross just, started talking. But he loved being out in the field, talking to farmers, and building relationships, which resulted in a lot of the amazing work we do. But 3 of the most important relationships that he pulled together over the years were these 3 people. So Dale Huss, Seamus Farms, the relationship that they built together resulted in the Castroville Slough Treatment Wetland and Bioreactor. So Ross bugged Dale for about a decade about that piece of land. And in 2016, Dale finally said yes and allowed us to take over the lease from PG&E and resulted in that wonderful habitat that was built along Highway 1. Hugo Titino, the patriarch of the Oceanist Farms, he befriending this wonderful man resulted in the Titino Ponds and the Titino Wetland Restoration Project. That larger one that was 35 acres next to the railroad track, Ross bugged Hugo for longer than a decade on that one. And eventually Hugo said yes. And then halfway through the purchase, Hugo passed away. So we named the whole project after him, but that was in the middle of COVID. He didn't die from COVID, don't worry. But it resulted in this protracted purchase. Nobody was out doing anything. Everything was over Zoom, and it was quite a process. But daughter took over, Kathy, and Ross had been working with Kathy on the purchase of that project, and then just kind of kept a relationship going with her because she was then taking over kind of the management of the family business. And one day she called up Ross and said, well, I have some land, but it is not in Moss Landing, it's in Pajaro. Do you want to come and look at it? So the property was Beach Ranch, which was pretty neat. So Kathy and Ross went there and looked at Beach Ranch, and it was, outside of our wheelhouse, the size of the darn thing. So Ross reached out to the land trust, and the rest is history. But it all comes back to those relationships and the people and keeping in contact with people out in the field. So I just wanted to pull it in at the end. All the things I've talked about, regional coordination, coastal resilience planning, habitat restoration, water quality improvement, wetland monitoring assessment, it's all going on at Beach Ranch, which is really amazing. And the Land Trust is leading an amazing job out there. And these stars are kind of the ones that CCWG is helping out with out on site. So thank you all. That's it.
Your water quality, Lower Paparo's got levees. Are you gonna do them on the inside of the levee or on the outside of the levee?
We are talking about that very question. We are. And how we want to, yes, do we want to design it so it's within the agricultural landscape or within the conservation area? And I think it really...
Can you go back to that slide showing the Lower Pajaro? Just because I think that gives...
Yeah.
And just pointing out what Kevin was talking about, and what Kevin is helping the Land Trust currently with. It's Beach Ranch, which includes Beach Ranch and its 2 parcels along the Watsonville Slough, but additional parcels adjacent to it where we're working on establishing restoration easements. So this is the entire area where the Land Trust, through this NOAA grant, with our partners, Watsonville Wetland Watch and Central Coast Wetlands Group and the Coastal Conservancy and TNC, are planning for all those things. But the questions like that are things that we're in the very early stages of figuring out.
Yeah.
So it's like we're building on everything that Kevin just talked about to us for the last hour to implement over the next 5 years in this region along the Watsonville Slough, where it comes into the Pajaro River in the Pajaro estuary.
So this cleanup of wetlands, you talk about the water quality improvement. I assume that changes the groundwater quality. And I'm just wondering, does that benefit communities in terms of the water that we drink? And what is the primary driver? I mean, there's also the habitat improvement. There's also more absorption of storm surge. So what are your kind of prioritized drivers?
It started out as improving water quality. Absolutely. In the Morro Cohoes.
Groundwater?
Surface water quality.
Surface water.
Surface water quality. The Morro Cohoes Slough has a very strong clay pan underneath it, so there's not a lot of connection between the shallow groundwater and the groundwater that people are pumping up and either putting on the farms or putting into the tap. So the work we were doing was really addressing surface water quality runoff before it got into the estuary. The benefits of the project then went on to include habitat restoration for the threatened and endangered species, and also providing floodplain resilience for large storm events. So it all kind of ties together on a landscape level, but really the initial push was addressing water quality issues in the Morro Cohoes Slough.
For the habitat, really?
Yeah, okay. And to address the amount of runoff of nutrients from the watershed into Monterey Bay, into the sanctuary, trying to reduce that. And we've done studies since this, starting in 2020, for 4 years, we got an EPA grant looking at the relative impact of nutrients from the watershed on harmful algal blooms within the Monterey Bay, and linking the specific nutrients that are leading to specific species of HABs going on with a lab at Moss Landing Marine Labs. So that was
okay.
Yep.
Thank you.
Yeah.
Since you talked about specific pollutants, you talked a lot about nitrates, but you didn't mention phosphorus.
Yes, and there is a graph. I'm almost there. Here, we have one of these for phosphorus, but it doesn't look as good.
I was wondering if the treatment ponds worked better than the bioreactors for that.
Potentially. So we were, there is an effect. It just takes a lot longer. It's more like way out here, and you do get down to much lower. But the reactions that are taking place in the wetland aren't as amenable to breaking down phosphorus. It's more of just a filtering effect. We did do some studies, though, looking at utilizing biochar for the removal of phosphate and phosphorus from. We were focused on the wash water coming out of the lettuce washing plants in the city of Salinas that ends up in their industrial wastewater treatment facility, and seeing if we do pre-treatment using biochar. They just have so much water coming out of the washing plants in Salinas that the volume the amount of biochar you would need is just astronomical. But the idea was that if we could use the biochar to remove the phosphorus, we could then use the biochar as a soil amendment out on the farm and start getting a circular movement of nutrients through the system. But it's still ongoing. Yeah. No?
I'll save
Okay.
I'll save my questions.
Have you looked at the difference or at the fish or the effects of your work over time on the fish living in the bin?
We have looked at the impacts of some of our restoration projects on some of the amphibians. So some of our projects were focused on long-toed salamander habitat restoration up around the high school in Upper Moro Coho off of Castroville Boulevard. And we have seen responses of increased numbers of small youngs in the pond. And then we have red-legged frogs everywhere. They're in the ditches, they're in the ponds, they're in the bioreactors, so they like any kind of wet area. We have been doing fish seines in the Moro Coho Slough, and there are tidewater goby. And the tidewater goby are interesting because they don't actually like what we consider really healthy water. They actually kind of prefer kind of low DO, sometimes hypersaline waters. So they aren't actually the best indicator of what you would want to see. But they are a threatened species. And we have been doing beach seines in Pajaro as well. So
I was thinking, you're reducing the amount of bad things going into the bay. Mm-hmm. So I was wondering if anybody was looking at the fish in the bay.
Our team is not looking at the bay, no. But I'm sure there are other people at the Marine Lab doing the stuff on the other side of the dunes. We stay on the back side of the dunes. We walk on the beach and we look out at the ocean and the whales. We just don't go out on the ocean.
You know your place.
And there was a question up here.
Yeah, you mentioned food safety issues
Mm-hmm.
a few times. What were you referring to?
Oh, yeah. Sorry, I just assumed things and then I need to explain them. Sorry about that. So food safety issues. Back in 2006, there was a major scare with contaminated spinach, which led to a lot of people getting sick. That resulted in the slow increasing pressure on farmers to remove any possible sources of contamination to their fields, which resulted in kind of the scorched earth policy that many large buyers have now, where they don't want to see any kind of native habitat around a farm. They just want to see dirt. And so that's the food safety issue. What it results on the landscape is that you've got growers on a landscape growing their crops. The buyers and their auditors come out to look at the farm, and they will say to the farmer, "I will not purchase your crops unless you do this, this, and this." And usually this, and this involves putting up large fences to keep wildlife out of farms, removing wetland or any kind of native habitat, or even they don't even want grass, they just want dirt. Some purchasers. So when you have a treatment wetland that's going in the middle of an agricultural landscape, you have to be cognizant of what will the effect of my restoration efforts be on the farmers that are growing next to me. What are their auditors and their buyers going to be saying to them? And I've actually gone out and talked with this farmer a few weeks ago. We keep a good relationship, but he's been told by one of his buyers he is requiring a food safety fence from here to here that's 8 feet tall. because of the potential for deer or any kind of other organism going from here onto here. He's also said that if it were today, he would not agree to this type of project in the middle of the landscape, which is sad here.
Salmonella and that kind of pathogen?
Yeah. There's been a lot of studies on the actual sources of the pathogens, and usually it is not a natural source. It can be other sources. And there are general agreements across the industry. One is called the Leafy Greens Marketing Agreement, which sets what's supposed to be the level of safety out on the farm, but buyers quite often push beyond that and put pressure on the growers to do more than what's in the Leafy Greens Marketing Agreement. So it makes doing restoration in agricultural landscapes harder and harder. Yeah. Yeah.
So when you talked about the measuring your success, the graphs mostly looked at nitrate concentration.
Nitrate, ammonia, and phosphate were the three we're mainly looking at.
But I didn't see anything that said like this is what the eutrophication looks like, or this is what bird diversity change, sort of like end things.
Because I could only fit so much into a trust talk. But we have monitored birds, and we've looked at bird diversity and abundance through time. That's a larger scale issue, though, with the Pacific flyway and migratory birds and overall impacts across the entire West Coast. What we have found is that putting these brackish and freshwater habitats on the landscape adjacent to Elkhorn Slough has kind of increased the diversity of habitats available in central Monterey Bay, allowing birds during different tidal heights to come to areas that are potentially not inundated. So it's just increased the ability for the birds to move around. And then your other question was about kind of
about eutrophication. I was mostly just interested in knowing how you chose your monitoring or your metrics. Not necessarily the results, I'm interested in that too, but just how you chose those. It sounds...
Yeah, a lot of it was initially just water quality metrics, looking at the impacts. But for each of the restoration projects, we also had this great bird monitoring guy named Rick Fournier, and he'd come out and he'd monitor all of our birds, all the sites for birds, and so we have those data. And we did some amphibian surveys with one of the folks here at UCSC, Gage Dayton. He came out and did surveys. So monitoring a little bit of everything. Yeah, we put out trail cams too. So. Oh, yeah.
I'm curious about the battery incident.
Yes. I am not on, I forget what the name they call themselves. There is a research group at the Marine Lab who has been looking at invertebrates, fish, plants, and then the actual sediment, tracking the movement of the heavy metals through the system, looking at potential for bioaccumulation. We, as part of our estuary monitoring and our beach seines, we collected a few fish and brought them to the lab for them. But they have recently released a pretty comprehensive report on what they found so far. And it kind of is the opposite of what some of the EPA is saying. But it's, well, this is the way the data were collected from the Marine Lab versus the kind of government agencies was very different. The Marine Lab was looking at impacts, you basically had a whole bunch of fallout. So the battery's caught on fire. There's metal up in the air and all fell down on the marsh in a very thin amount. So what the Marine Lab did was took a very thin layer and looked at the concentration of the metals in this little thin layer because it's basically dust across the landscape. Whereas some of the monitoring done by the government agency was they took, a foot of soil, mushed it all together, sent it off for analysis, and all this heavy metals are then diluted. So it's a very different way of looking at it. At this point, they've gone out and monitored, the Marine Lab has gone out with their cool X-ray gun, they have a gun, and they shoot it at the dirt. And it tells you the composition of what's on the dirt. It's very much like Star Trek. But most of it's washed away. It's down either in the slough or out into the Marine Canyon at this point.
Oh, boy.
Yeah.
And have there been analyses of the effect on the wildlife in the slough?
They've looked at the potential for accumulation, of the heavy metals, and they found a slight amount in the invertebrates, but nothing else yet. So we don't know if the organisms that eat the invertebrates potentially will have it, but it's ongoing monitoring, yeah. There could be a whole talk on that. That could be one of your trust talks. Ivano could come here. He could tell you all about the battery fire.
Let's give Kevin a round.
Thank you, everybody. Thank you.